We sort of set out to take laser cutting as a process, as incredible one as it is, and systematically remove all of the things that sort of suck about using it.
So this is the Rendyr Optic, a 10-watt diode laser with this really cool origami style design that has like a cutting mat on the bottom and then it wraps around the whole machine to carry it, which is crazy. And they have just launched on Kickstarter. They've blown past their $10,000 goal and they're nearing in $1 million back. So Optic is claiming this is the first portable laser engraving and cutting solution that not only has integrated filtration, but also has infinite work area capabilities. Now, those are the claims that I usually love to test on this channel with cutting and power and laser dot size tests that you've seen before, but unfortunately I couldn't get my hand on one of those units, so I gave their founder and CEO, Kaelum, a ring.
My name is Kaelum Hasler.
So Kaelum is a recent industrial design grad from Virginia Tech, but the story actually starts when he was in college with an old laser machine from the 1980s.
So I went to Virginia Tech's industrial design program because I had always wanted to design consumer electronics. And so I was excited to get into the program and actually start using these types of machines. So CNC machining, 3D printing, laser cutting are all very important pieces when you're doing any sort of physical prototyping. And that's what I was really excited about is actually taking all of my CAD models and designs and actually turning them into real actionable prototypes that can be used and evaluated. And I had, at the same time, always wanted to build a laser cutter because I, just like everyone else, you always want like a laser cutter. 3D printers are cool and stuff, but like you could do real stuff. When you have a laser cutter, you're no longer limited to plastic models. You can make real things out of like wood and optically clear plastics and fabrics and things that would take a next level of time and finalization to CNC, would take a long time to 3D print, but are perfect for laser cutting. But we're actually very limited options when it came to laser cutting. In my specific program at the time, there was a single laser cutter from the 1980s that the entire school of architecture and design had to actually rent out for their projects. And so you couldn't really ever use laser cutting for prototyping. You had to do all your prototyping by hand with paper and a matte knife, and then take your final design and then laser cut your final architecture model or your final product model or whatever you're trying to do. And so I had lots of experience building 3D printers because when I was in school, I had a tiny little 3D printer that I kept on my desk to do prototyping with and to do rapid iterations with. And what I really wanted was that equivalent, but a laser cutter. And so there's all these different issues that keep you from doing that. The fact that you need high voltage power supplies, water coolers, and $1,000 air scrubber the size of a mini fridge in order to deal with those fumes. And the fact that the type of machines that I wanted was between $5,000 and $50,000. And so all of those things made it prohibitive to actually obtain a laser cutter and use it. And so I strapped a Chinese laser diode to a 3D printer and started experimenting with laser cutting and laser engraving. And it wasn't much, but I knew that there would be a way to take laser cutting as a process and make it as accessible and as user-friendly as 3D printers.
Now, more than likely, we've all played around with machines and tinkered with them to try to make them better. This is really common, especially with 3D printers and the cheaper ones that you can get. But it's a whole nother thing to take that tinkered with 3D printer and actually turn it into a product that you can sell. It's at this point that Kaelum parted with Martin Angst at Virginia Tech to co-found Rendyr. They took this hacked 3D printer and laser and turned it into a real product.
I actually met Martin through both of our work in robotics research at the school, and we founded the company and we started doing entrepreneurship competitions and pitch competitions. We won a little bit of money here and there. We won a free year of rent at the corporate research center. That allowed us to get some prototyping equipment and then to keep refining our prototypes and to keep working through all of the challenges. And then we just kept our heads down, kept working through school. So I was also a student and Martin was also a student, and we had the first couple of years of the startup's existence, we were both in school, and during school we were a part of 2 accelerators. So we did Lighthouse Labs in Richmond, Virginia, and then we did RAMP, the local accelerator here. And then we launched.
Now, you're probably watching this channel because you love to make things and you like to see all the tools that you can use to do that. But you might be like me and you want to go even further and see how you make the things that you use to make. So how do you make the 3D printers and the lasers and the CNCs that we all like to use? Like, seriously, where do you even start? Do you like call up China and overseas and ask for a prototype? Do you find some manufacturer in the US? I mean, where do you actually go to take this crazy idea and actually start to turn it into a product that you can manufacture? And it turns out with Kaelum and his team, that journey starts with a trip to Home Depot.
When you're doing a really early prototype and you're just trying to see if something works, honestly, just go to Walmart and Home Depot and get whatever you think you'll need to prove out your idea, because you're really just trying to create a proof of concept. You're just trying to show what is possible to either convince yourself or to convince other people that your idea is valid. And so that's what I would say is always start prototyping with whatever you have around you, with the lowest hanging fruit that it'll take to work out your idea for yourself or to work out your idea for other people or other groups that are around you. And after that, it's really about figuring out what your list of priorities are and the thing that you're designing and the thing that you're creating. You need to figure out what your market is, what resources you have to work with. And then once you have your feature set nailed down, then it's really time to start the actual work of engineering, figuring out the cheapest and most efficient way to get to your product. And of course, the places that you source these parts from really depend upon the kind of thing that you're doing. But for us, it was a lot of getting things quickly first from Amazon and then finding the actual manufacturers of those parts so that we can work with OEM manufacturers for all of our components.
Have you had enough time to like just actually build stuff with it, or are you just building the company and building it?
I'm finally able to start using the Optic, and it is extremely exciting. I engraved an iPad for my dad. He's started his media business recently. That's what the sign and the iPad for in our marketing material. When we cut the really big sign and when we engrave the iPad, that's his logo and his company. So it was really fantastic to be able to make him a gift with the thing that I made. And then I was able to make stamps, which I had wanted to for a long time. My partner and I are really into stamps and stuff, and that was fun. And I got to work on making that macro pad, and that's a huge passion of mine, mechanical keyboards and custom things like that. So that was a hugely fun project, but I'm very excited to start making more and more projects. And there's a few in the pipeline that I'm excited about finishing up.
So as you're looking at lasers, you're going to see pretty much two different categories. One are going to be CO2 machines. These have like a big glass tube in the back of the machine. These are going to be like Glowforge or the Full Spectrum Muse or the bigger, more industrial units that you might see from OhmTech. All of those I've reviewed in the past. You can check them out right up there. Or you're going to see diode machines. These are going to be usually cheaper. They're going to be smaller just in the overall size, but they're going to be a lot less powerful. Normally they're open air, and the laser diode units really aren't going to get much higher than 10 watts. And because of all of that, they're usually a good bit cheaper. And you'll see these from companies like O'Toole or SculptFun or AtomStack or even Niji. And actually on the Kickstarter website, they compare the Rendyr Optic to a Niji machine so you kind of see how the filtration works. But that actually was a key design decision from the very beginning for Caleb and team to pick between those CO2 machines and those laser diodes.
So all of the diodes at the time I wasn't really happy with. A lot of them had efficiency issues where they were overheating because they weren't efficient enough to properly cut your material at a rate which would not burn it while also being thermally stable conditions for the laser to continue to operate. There were really great things, and there are great things about diode lasers that we wanted to keep with our system. And so what we did is we looked at the diodes that are currently used in these import machines, and not to get super technical, but the name of those diodes are A5, A7 Nichia diodes, and they typically are rated to run at 3 watts, and then they have a peak optical output of about 5, which is fantastic for cutting paper and cardboard and all of the paper products. But when you're cutting things that are thicker, that's really when you start to notice the deficiencies in a diode system. And so what we actually do with the Optic is, instead of using the 3 watt, which can be pushed to 5, A5, A7s, we actually use 7.5 watt peak output diodes. And what we do is we use 2 of them, and then we combine them using an optical combining element, and then we collimate it using an FAC lens, meaning that we have about half of the power of a stand 40 watt laser cutter with like 1/10 of the size and form factor of that laser diode. And so by completely creating a custom diode specifically for the Optic and the Optic's filtration and cooling system, we were able to get desktop level laser cutter performance in an incredibly small form factor that is really easy to maintain. So there's also some sort of second layer disadvantages to a CO2 tube system. One of them being that they continue to degrade over time, even when you're not using them. They have a shelf life, even when they're not under use. They tend to have about half of the lifetime that the diodes do, meaning that you need to replace them more often. And there are also multiple lenses that need to be maintained and taken care of. Unless it's a Glowforge and for whatever reason, they decided to physically remove the glass tube as a part of the y-axis. Not entirely sure why they did that.
Glowforge is probably the machine you've been thinking about the most, especially when we talk about Kickstarter lasers. In fact, at the time, they were the largest Kickstarter like ever for a machine like this. They raised $27.9 million for their Glowforge machine way back in 2015. But I wanted to get Kaelum's thoughts on how he would compare Glowforge specifically to the Rendyr Optic and where he would see it fit in the whole laser ecosystem.
So the first thing I would do to make it an equal comparison is take the Glowforge and then append on their $1,000 filter, and then you're in the proper place to compare both. Right out of the box, we have roughly the same build volume in terms of what you're actually able to cut either within the bounds of our cutting mat or within the bounds of their machine. And it really depends upon what you're going to be doing. If you want the ability to engrave a design of any size, I would go with the Optic. If you want the integrated filtration aspect, then I again would go for the Optic. And if you want an incredible software experience, I again would go with the Optic because Lightburn is the best software available for laser cutting. You don't need to be attached to a network to use the Optic. You don't need high voltage power supplies or to be able to plug in or to be able to run a tube out of your window because the Optic uses USB Type-C for both data transfer and also for power. So the Optic just uses the same power supply that you're probably already using for your laptop. And generally, if you don't want all of the headache of setting up an industrial piece of machinery in your studio, in your apartment, in your house, in your office, then again, I would go with the Optic. I'm a terrible person to ask whether or not you would buy the Optic or buy the Glowforge, but we've really designed the Optic to be as user-friendly as possible and to be the easiest, cleanest, and safest way to get into laser cutting and laser engraving.
Okay, so let's actually get into the specifics of the Rendyr Optic. But before we get into some of the design details and the functions, I think the thing that stuck out to me the most was the actual overall aesthetics of the machine. And this is one of the very few machines you probably wouldn't mind leaving out just because it doesn't look super ugly.
Probably the thing that jumped out even the most when I first saw it was just the aesthetics of it. We've been talking about kind of the import machines, and those are just ugly. I mean, like none of them really look that great, yeah. But this one, it almost looks like a Sonos speaker when it's wrapped up. It looks really cool sitting.
Yep.
So where did that come from, that design like aspect? Is it just because from your industrial design?
It's 100% just from my background in industrial design. I set out at the very beginning to design consumer electronics, and instead of thinking about designing the laser cutter as a laser cutter, we were thinking about designing the laser cutter as a consumer electronic, as a piece of consumer electronics. We've tried to go about it in the same way that an iPad was designed or a Sonos speaker was designed, that it was going to be touched and handled by human beings, going to be brought into their home and going to stay and sit in their home. And so all of the different design considerations that go into that.
Okay, so there's two major design capabilities that I think are unique to this machine. And first is filtration. If you've seen any of my diode laser reviews, you know pretty much my biggest caveat is that there is usually no filtration included with the machine. I think the two trees that I recently reviewed does have like an enclosure and it does vent out the back, but normally these things are open air, so it's on you to either build an enclosure, figure out how to vent everything out, or just put it outside or put it in a garage with a big open door like what I do. Now, Rendyr actually does something super unique.
All of the import diodes that you see, none of them have any consideration for filtration whatsoever. They poison you as soon as they come out of the box and you start cutting with them, unless you create your own evacuation system or you create your own filtration system. That involves creating an enclosure and running 4-inch tube to an air scrubber or running that 4-inch tube out of your window. And that is the biggest hulking elephant in the room when it comes to laser cutting as a process, is fume management. And so we knew that would be something that we'd have to solve early on. And so going back to our unique architecture, that's actually one of the things that allowed us to do. By directly enclosing the x-axis, it means that we can capture the fumes as soon as they're created, rather than having to enclose the whole volume and then constantly filter out the entire volume of air. We're able to, like a vacuum shoe on a CNC, directly suck up the fumes and then directly filter them, meaning that we can make our filtration system extremely compact.
Yeah, because then you wind up basically with a cartridge system. Is that right?
Yeah, it's just like you put a water filter. Oh. And so you don't even need any tools or anything. You just pull it out of the left side of the machine and then put in a new filter and you're ready to go.
And the second feature I literally haven't seen on any other machine is this crazy folding mat that doubles as a cutting area as well as a case that you put your entire machine in. And honestly, this reminds me of a pack and play for any of you that have kids. We actually just had our third kid and she is sleeping in it right now, but it's basically like a portable crib. The whole thing folds up, but then the mat that the baby sleeps on also doubles in as a wrap that goes around the whole pack and play. And that's kind of what they're doing here with the Rendyr.
Just to go back and draw another sort of comparison to those import machines with the diodes on them, none of them have a cutting mat. So you get through your cardboard and then you cut down into your dining room table or your workbench or whatever you was unfortunately working on top of. And then we looked at the solution for larger, more industrial systems, what they use for their cutting mat. Some of them use a down draft table. Some of them just use a passive honeycomb table. Both of those solutions are totally fine. But we knew that we could combine the cutting mat with sort of protection of the machine when it's stored. And so it really came down to a feature set of having to be laser proof, foldable, and we knew that we wanted to make it easy to remove so that you could remove it to be able to engrave on pre-existing objects or index your design across larger cuts in order to have a theoretically infinite build volume. And so with that feature set in mind, really just hit the ground running and began prototyping, testing out a ton of different materials, a ton of different designs. We tried some designs that were all aluminum and then used a different type of aluminum for the hinges. We tried designs that use a variety of different materials, some with composites. But what we came upon with our sort of modern composite cutting mat, we're extremely happy with. And one of the advantages that our cutting mat allows over the other two options that I was describing, either having no cutting mat or a honeycomb cutting mat, is that we have that engraved grid on the cutting mat, which actually perfectly matches the grid in Lightburn. So that means when you're laying out a wallet or a phone, you can lay it out at specific intersections and grid lines, like at 5-7, for instance. And then you put your artwork in the same spot, and then you know that it is going to line up. And then with the series of snaps that we have that attaches the cutting mat to the bottom of the machine, there's, I believe, 10 of them. That means that whenever you take off the cutting mat and put it back on, it'll always line up perfectly to the machine axis.
Okay, so hardware is only part of the equation that you are dealing with when you're looking at lasers. And honestly, the thing you're going to interact with the most is actually the software. Now, Optic could have gone the route of the likes of Glowforge or Full Spectrum Muse, where they have their own software that you're kind of locked into. But instead, and this is a big plus for me, they are keeping their whole machine open to use whatever software you want. But they still are trying to bring in those custom features that are unique for their unit. And that is with a special build of Lightburn. If you have seen any of my other reviews, you know that I love Lightburn. I actually have a course on Lightburn if you want to check it out. And it is the piece of software that I use for all of my diodes and all of my CO2s. It just does an incredibly good job.
So we knew from the beginning that we wanted to use Lightburn, but from there, we put in a ton of work to make it so that the Optic version of Lightburn was as if we had built it from the ground up. So when you get an Optic, you'll get a license of Lightburn, and then you'll also get all of the Lightburn specific settings for the Optic. And so you have a material library specifically tuned for the Optic with hundreds of materials in it. You have Optic specific settings and macros. So there's extra buttons in the Optic version of Lightburn that's not in regular Lightburn. It comes pre-calibrated and programmed so that the grid that you see in Lightburn is exactly the same as the grid on the cutting mat. And then it's basically built from the ground up specifically for the Optic. So we have the advantages of both using a universal laser software with all the great features, and it also comes pre-calibrated and fully ready to go with the Optic.
And that brings us to today, or really a few weeks ago, when this video comes out with the launch of their Kickstarters. Now, I know Kickstarters can be pretty controversial, especially in the maker community. I know with 3D printers, we see this a lot, and people feel like they get burned because sometimes those units never actually come to market. And people feel maybe this is like a marketing push from these companies and not really a full crowdfunding Kickstarter. But Optic really feels like a crowdfunded unit because this is their very first thing and they're literally raising the money to produce the machine. But with all the controversy aside, I wanted to see what it's like on the other side of the screen. What's it like to actually launch the Kickstarter? After you put in all of this work, you do all this prototyping, you work on all of this marketing, all of this collateral, and then finally you hit launch or live, or actually I don't know what happens, but then you start to see the first backers come in.
It has been incredible, and we feel so lucky about all of the support that we've gotten, all of the people sharing us, both within our local community and across the larger maker community in general. So we're incredibly blown away by the amount of support. And now we're just really excited to start making these machines and shipping them out to the backers. As the backers and the orders started coming in, it was just really exciting to see all of that work, not just of the previous days, but of the previous 4 years that we've been working on this. It was just incredible seeing that people actually wanted what we were working on. We had done tons and tons of customer discovery and outreach and working with beta testers and beta users and really trying to understand how to make the most accessible laser cutter that had all of the features that our customer base and user base is looking for. You never know until you actually put yourself out there. So we're just incredibly excited, incredibly happy with all the with the results so far of the Kickstarter.
Okay, so they have sales. What's it going to be like to bring Optic to market?
So we have 10 batches of parts from all of our manufacturers, and we're going to be putting together these machines starting the next couple of days. And those are going to be used for performing accelerated lifetime testing, working with third-party laboratories in order to certify us for sale in North America. We're working with TUV Rhineland, and they're helping us to make sure that we're following all of the safety standards and certifications that we need. So some of our pre-production machines are going to be used for that. But the real thing, the largest thing that our pre-production machines are going to be used for is optimizing our assembly, manufacturing, and quality control processes, because that's all going to be happening in here at our headquarters. Because we're getting our metal parts from one manufacturer, we're getting our plastic parts from a different manufacturer, and we're getting some other parts from a third manufacturer, and they're all coming here, and we're doing all of the assembly here and all of the quality control and shipping out from our location here. So we're going to be setting up our assembly lines, and our processes is the next step to making sure that we get these optics out to our backers as quickly and efficiently as possible.
Now, when this video goes live, their Kickstarter is still running for about a week if you are interested in the unit. And once the Kickstarter is over, I'll make sure that link directs to where you can actually pick up this unit in the future. Now, I would love to know what you guys actually think of this machine. Is this something you would be interested in? I know it's at a much higher price point than some of the other Diode machines, but it also has some pretty crazy features that are very unique to the Optic. Also, I would love to know what you guys think of this more interview style format for a video. Usually we test the actual machines and hands-on, but I also love to get the backstories of the development of those machines as well by talking to the people that made them. And then finally, I know we've been talking a lot about Glowforge in this video. I've actually done a full review of it, and we're gonna check that out right now. And until next time, go make or break something in your shop. See you guys.